Good morning. Now this is the class 7 of module 1, zeroth law of thermodynamics. Now in this section what we are going to learn is a lot of definitions, that is what is meant by thermodynamics, what are thermodynamic system, what is surroundings, then what are thermodynamic variables, then what is a thermodynamic process like reversible process, isothermal process, then adiabatic process, isobaric process, then isochoric process, then various types of systems like open system, closed system, isolated system, like that. So we are mainly going to learn about a lot of definitions that you come across while learning thermodynamics. Okay, so let us start the class. Thermodynamics is a branch of science which deals with the study of transformation of heat energy into other forms of energy and vice versa. That is, when you rub your palms of your hands together, it will get warm. Why? Because the mechanical work that you are doing against friction is now converted into heat energy. Similarly, a heat engine, it converts heat into mechanical work. So thermodynamics is a branch of science or physics which deals with the transformation, which deals with the study of transformation of heat into mechanical work and vice versa. Now, these are the definitions that you have to study, all the definitions that I have underlined. Now, what is a thermodynamic system? That is an assembly or collection of a extremely large number of particles such as atoms or molecules characterized by certain variables like pressure, temperature, volume, etc. is called thermodynamic system. Suppose that you have a gas enclosed in a cylinder fitted with a piston. Then that gas actually forms the thermodynamic system. And now the variables such as temperature, pressure, volume, which characterize the system, are called thermodynamic variables or thermodynamic coordinates. Now anything outside the system which has a direct influence on the system are called surroundings of the system. So in the above case, we have studied about an example for a gas enclosed in a cylinder, right? So in that case, the atmospheric air surrounding the cylinder and the piston forms the surroundings. That is, they are called the surroundings. Okay, so we have studied the definitions for the thermodynamic system, surroundings, and thermodynamic variables, and examples also. Now, what is meant by an open system? It is a system which can exchange both matter and energy with the surroundings. Now, what are closed systems? Systems which can exchange only energy but no matter with the surroundings. Now, last one is isolated system. It is a system in which energy and matter cannot be exchanged with the surroundings. Now, thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium if it does not have any tendency to change its thermodynamic variables with the time. Thermodynamic variables we know, we have already discussed, which are they? Temperature, pressure, and volume. Now, for a system to be in thermodynamic equilibrium, the following three equilibria are to be satisfied simultaneously, which are they? One is thermal equilibrium, that is, a system is said to be in thermal equilibrium if all parts of the system are at same temperature and this temperature is identical or equal to the temperature of the surroundings. That is, a system is said to be in thermal equilibrium if all parts of the system are at same temperature and that temperature is equal or identical to the temperature of the surroundings. Now, a system is said to be in mechanical equilibrium if no unbalanced forces exist within the system itself or between the system and the surroundings. A system is said to be in chemical equilibrium if it does not undergo any change in density or chemical compositions. Okay. So all these are very important. Another important session is about thermodynamic process. So a change in a thermodynamic system which results in the change of a thermodynamic variable is called thermodynamic process. So first of all, you have to define what is meant by a thermodynamic process. Then you have to explain various processes like reversible, irreversible, isothermal, adiabatic, isobaric, isochoric, etc. So let us begin with the reversible process. It is one which can be performed in the reverse direction. That you know, any process that can be performed in the reverse direction is called reversible process. But how? In such a way that all changes produced in the system and its surroundings during the direct process are exactly reversed with the reversal of the original process. That is, if you are able to reverse a process just by reversing the conditions, then we can say that that process is reversible. Now, the three conditions for a process to be reversible are absence of dissipative effects such as viscosity, friction, electrical resistance, magnetic hysteresis, etc. It should be very slow. Then temperature of system and surroundings must be nearly equal. So almost all natural processes, they are irreversible. However, many processes can be made to satisfy the conditions of reversibility by adjusting the controlling factors. Now, some examples for reversible processes are conduction between two bodies at the same temperature, chemical reactions in a secondary cell, etc. Now, irreversible process. A process is said to be reversible if the changes accompanying it are not reversed with reversal of controlling factors. Examples: heat produced due to friction, Joule Kelvin effect, etc. Now, causes of irreversibility are lack of mechanical, chemical, and thermal equilibrium during the process, then involvement of dissipative effects such as viscosity, friction, etc. Now, what is a cyclic process? A cyclic process consists of a series of changes which returns the system back to its initial state. Now, thermodynamic processes are again classified into four, as I said earlier. One is the isothermal process. What is it? A process occurring at constant temperature. Adiabatic process. In an adiabatic process, no heat enters or leaves the thermodynamic system during the process. Isobaric process, it is a process that takes place at constant pressure. Isochoric process means a process that takes place at constant volume. So among these, we will study in detail about isothermal process and adiabatic process. Okay, so this is very important. So this session as a whole is very important. So please go through this class 7. Okay, and now we know that a change in pressure and volume of a gas without any change in its temperature, that is called an isothermal process. So here there will be a free exchange of heat between system and the surroundings. Now the two important conditions for a process to be isothermal are, that is, walls of the container of the system must be perfectly conducting, because that will allow the free exchange of heat between the system and the surroundings. Next one, the expansion or compression accompanying the process should be slow so as to provide sufficient time for heat exchange. Examples are melting of ice at its melting point and boiling of water at its boiling point. Now, since temperature is constant in isothermal process, pressure and volume are related by Boyle's law, that is PV equal to constant. So that is the equation for an isothermal process. Now, if we plot a graph between volume along x-axis and pressure along y-axis, keeping temperature constant, then we will get a curve like this as shown in figure. They are called isotherm or isothermal curve for a given mass of gas at a given temperature. Okay, so here you can see three isotherms. The slope is dP by dV, or it is minus P by V. Now, adiabatic process. It is the one in which there is no exchange of heat between system and surroundings. This is a change in pressure and volume of a system in which temperature also changes. Now, the two conditions for a system, for a process to be adiabatic is that, as I said earlier, there is a slight change, that is, walls of container must be perfectly non-conducting. Okay, why? In order to prevent heat exchange between system and surroundings. Now, expansion or compression should be sudden. Why? So that there is no time for heat exchange. However, these conditions, both conditions, are very difficult to be realized. Therefore, perfect adiabatic changes are impossible. Some examples are sudden expansion of air when inflated tire burst, expansion of steam in cylinder of a steam engine. Okay. Now, a curve which represents variation of pressure and volume of a given mass of gas for a adiabatic change is called adiabatic curve. See, it is shown here. The slope of the two of the adiabatic curve is the same as that of isotherm, but the slope of the curve is different. Here the equation is of the adiabatic equation is PV raised to gamma equal to Ka constant, whereas gamma is Cp by Cv, that is specific heat of gas at constant pressure by specific heat of gas at constant volume. Slope is dP by dV, or that is equal to minus gamma P by V. Now, zeroth law of thermodynamics. That is a very possible question. That is state zeroth law of thermodynamics. Okay, this law states that if two thermodynamic systems A and B are separately in thermal equilibrium, that is with a third system C, then the systems A and B enter in thermal equilibrium with each other. That is, zeroth law states that if two systems A and B are in thermal equilibrium with a third system, say C, then the two systems A and B are in thermal equilibrium with each other. Okay. It is illustrated with an example. C A and B are separated by an adiabatic wall. Suppose that the systems A and B are in contact with a third system C through an adiabatic wall. Now the result is that the systems A and B will attain thermal equilibrium with each other. So this zeroth law actually forms the basis of the concept of temperature. What is temperature? We know it is the physical quantity which determines whether a system is in thermal equilibrium with another system is called temperature. Okay, so study the statement of zeroth law of thermodynamics. That is a very important question. Now equation of state, that here I am presenting only its definition. Why? Because we have already discussed about equation of state in detail in our earlier classes. Okay, equation of state is a thermodynamic equation relating state variables that describe the state of matter under a given set of physical conditions such as temperature, pressure, volume or internal energy. It is useful in describing properties of fluids, mixtures of fluids, solids and the interior of stars. Now another possible question is distinguish between expansivity and compressibility. So expansivity, let us see. It is an important property of substance is how its volume will respond to changes in temperature. Okay. Again, gases respond to changes in temperature, whereas solids and liquid will have more modest, that is, responses to changes in temperature. Now the definition for expansivity, it is also called by the name expansion coefficient, is given by alpha is equal to 1 by V dou V by dou T at constant pressure. The 1 by V term is needed to make the property intensive and thus able to tabulate in a useful fashion. In case of expansion, volume increases with increasing temperature, so partial derivative will be always positive. So expansivity is nothing but it is a factor that tells us how the volume of a substance will respond to changes in temperature. It is represented by the letter alpha, and study this expression also. Okay. Similarly, compressibility. It is a property that tells us how compressible a substance is, that is how much a substance is compressible. For example, gases are highly compressible. When subjected to high pressure, their volume will decrease significantly. However, solids and liquids are not as that much compressible as gases. However, they are not entirely incompressible. High pressure will lead to a decrease in volume. Okay. So compressibility, it is mainly defined by the fractional differential change in volume due to change in pressure. It is given by represented as Kt is equal to minus 1 by V dou V by dou P at constant temperature. Now negative sign, keep the value of Kt always positive. Why? Because an increase in pressure will lead to a decrease in volume. Okay, so what is compressibility, what is its expression, how it is denoted. Similarly, you have to study expansivity. So that is one possible question. Distinguish between expansivity and compressibility. Then state zeroth law of thermodynamics. Then distinguish between isothermal process and adiabatic process. Then describe in detail thermodynamic processes. There you have to define what is a thermodynamic process. Then you have to individually explain isothermal, adiabatic, isobaric, isochoric, reversible and irreversible processes. Okay, then about thermodynamic equilibrium's definition. So this class, everything that is discussed in this class is very important. So please please go through it. Okay, so for today this is enough. Thank you.